Before this video begins, head over to Jensen Math on YouTube. Subscribe, hit that bell. Thanks, enjoy the rest of the video.
To understand what double angle identities are, it is first necessary to understand what an identity is. So an identity is an equation that is true no matter what value is assigned to any of its variables. So a very simple example of this would be like 3x equals 12x over 4. And then we can continue to simplify this until x just equals x.
To be able to prove double angle identities, we also have to know compound angle identities. So first we have this graphical explanation of it. So start with sine x plus y right here. Sine x plus y is equal to sine x cos y plus cos x sine y, as you can see over there. And if you would want to reverse it, so you have x minus y, you reverse the sign in the middle. Then we have cos x plus y, which is equal to cos x cos y, subtract sine x sine y, which gets you cos x plus y. And if you want the reverse of that, you reverse the sign in the middle. Now we're going to be looking at proving the simplest of the double angle identities. These are the three simplest ones, sine 2x, cos 2x, tan 2x, but we're only going to be proving sine and cos. So we can start off with sine. So sine of 2x is equal to 2 sine x cos x. And now if we remember our compound angle identities, we know that sine, we can split this up, it's x plus x, and then that's a compound angle identity. So we can do sine x cos x plus cos x sine x, rearrange that. And then these are the same thing, so we can just combine them into 2 sine x cos x. And there's the identity. We can move on to cos. Cos has 3 possible identities, and this is just the first one. So it's equal to cos squared x minus sine squared x. And again, we can split this up. Cos x plus x, there's our compound angle identity. So cos x, cos the second variable, x minus sine x, sine x. And these are the same thing, so we can just combine them. Cos 2x minus sine 2x. Now we can do the next one, which is cos 2x equals 2 cos squared x minus 1. And now we already know that cos 2x is equal to cos 2x minus sine 2x. So we can substitute that in. And then we can substitute in the sine 2x, and we can put 1 minus cos squared x. So that's equal to that. Then we can put in the negative and apply that to all of that. Minus 1 plus cos 2x, and then we can combine them, we get 2 cos 2x minus 1, so those are equal. And we have the final identity, cos 2x equals 1 minus 2 sine squared x. And again, we can already put in this because we know that is true. Now instead of putting cos in for sine, we can put a sine variable in for cos. So this is 1 minus sine squared x minus sine squared x. And we know that negative sine squared x minus sine squared x is 1 minus 2 sine squared x. And those are the simplest identities. Now that we've proven the double angle identities, we can move on and apply them to more complex trig identities, such as cosecant of 2x plus cotangent of 2x is equal to cotangent x. So we can start by making the cosecant 2x equal to 1 over sine 2x plus cotangent, which is cos 2x over sine of 2x. And then if you notice, we have a common denominator already, so we can already combine the equations. So it's equal to 1 plus cos 2x on the numerator, and we just have sine 2x. Now let's first make sine 2x into 2 sine x cos x, as that's our identity, double angle identity. Now I'm only doing the sign right now because that's the only possible identity sign can be. Now we have to find an identity that we can use for cos 2x. So if we go over here, we have the 3 possible ones for cos. We want something that maybe subtracts 1, so we can use this one here, and also the 2 will cancel out, so I think this one's what I need to use. So let's substitute that in. So we have 1 plus 2 cos squared x minus 1 all over the 2 sine x cos x. And then the 1 minus 1, so we just have 2 cos 2x over 2 sine x cos x. 2's can cancel out. One of the coses will cancel out. We're left with only cos x over sine x. It's the simplest we can get this. We go back up to cotangent. Cotangent is also equal to cos x over sine x. Now we have left side equal the right side.